All right, so good morning, good evening, good afternoon, and welcome. So today's lesson is lesson 7.4. We skipped 7.3. We're going to do 7.4, and I'm only going to do half of the chapter on this. This is a very difficult lesson for a lot of the students to guys understand, and so we'll go from there. If you have the notes, if you don't have them, please go to Canvas and print them out. If you do, here's your essential question about talking about perfect squares today. Perfect squares are 4, square root of 4 is 2, 9, which would be 3, 16, which would be 4, 25, 5, 36, 6, so on and so forth. Big thing with the radical expressions is that you guys need to have 4 topics done for this week and a total of 28 coming up by this Sunday. Okay, the clock is ticking on that, and everything's already up on ALEKS. I skipped. We're not doing bell work online anymore, or not on my video anymore, because we went to an online version that unfortunately you're not going to be able to do unless you're in class. So we're going to go from there. So we're just going to simplify radicals. And what a radical is basically it's the square root sign. Okay, so when this would be identified as a radical expression, okay, this piece of the puzzle right here, okay, this is a radical expression. And what this product property of square roots basically means is that if you multiply any two products together, okay, you would get 36, which would be the square root of 6, or you can do them separate. Okay, so if you multiply a bunch of different numbers together, so if you have a big number like 36, you can break it in half to 4 times 9, or ladies and gentlemen, see how the setup is here, or you can solve it for 36 or break it up, and if you break it up, you solve it individually. So square root of 4 is 2, square root of 9 is 3, and then you would multiply them together. 2 times 3 is 6, okay? So let's begin. This is what we're doing. We're simplifying this expression. So what I want to do is write this down on your paper on the left-hand margin, please. Please make sure you guys are fully aware. What we're looking for is a perfect square. So inside this bracket, we're looking for the square roots. And what our goal is to take this number here and to simplify it or reduce it down to a point where we cannot take out any of these square roots. Okay, so for example, if we look at this, ladies and gentlemen, can you take the number, as we're looking through it, you have to ask yourself, can we divide a certain number into this square root? Okay, so when I'm looking at this, the first thing I ask myself is, split it up. Now, is it easy to do? Sometimes it's not, sometimes it is. What I mean by that is, do you know your multiples of 4? Like 4 times 1 would be 4. 4 times 4 is 8, and then, well, let me repeat that. It would be, it's more of a, 4 times 4 is 8, then 4 to the third would be what? You have to count it out, okay? So what I want to make sure you guys is understand kind of the philosophy and principle behind. I need to make sure you guys know what these are. So we're gonna kind of break this up to make it so that we can either have a 4, 9, 16, or 12. So is there any number, can you divide 4 into 52 is the first main, I guess, response. And the question, of course, would be, yes, you can. So if I were to do an old school division problem, okay, 54 divided by 2, I'd get 1 and 12, so my other number is 13. Okay, so do I know off the top of my head that 13 times 4 is 52? No, I do not. Okay, so that's one of those aspects that I want to make sure you guys look at first. Okay, so another way, instead of going to this point, all right, would be to start with the number 2. So we're going to start with 2 on this example, and then it would be 2, and then if I divide that into there, it's going to be 26. And then you can take this 26 and you break it down again before. Kind of like if you guys remember the old tree root that you used to do, or I can't remember the proper terminology of it because it's 8th grade math, but you guys know what you do here, where you could create basically a chart going up and multiplying the numbers. So what I mean by that is 26 times 2 is 52, and then 13 times 2 is 26. And can you break this down any farther? No, these are prime numbers, okay? So here's the setup that we have here. Now, what you're looking for is, according to the property we learned, is that, redo that, is that you can rewrite this as square root of 13 times the square root of 2 times the square root of 2. Okay, because that's what we got down here. We got 13, 2, and 2. That's how we broke it down. The question is can you simplify 13, 2, or 2? The answer is no, you cannot. But if you combine these two together, you'd have the square root of 13 times the square root of 4. And then now I ask you, can you solve for the square root of 4? Yes, you can. So the square root of 4 would be 2. Now, can you do anything else to this equation? No, you cannot. So you would write it simply out like this. Okay, so to simplify this equation here, all right, you would end up getting that. Now I know that seems very difficult and maybe it doesn't make sense, but please stay with me during this lesson. Make sure you write this key down because I wrote it on the board on my left-hand side over here, but I want to reference back to this multiple times. All right, so let me walk through with this to you guys. So look at your 54. Look at your numbers and you tell me what number can 4 be divided into this? No, it can't because 4 and then 14, but can 9? The answer would be yes, okay. What two numbers would multiply? It would be 9 and 6. 9 times 6 is 54, okay. If you set that up, ladies and gentlemen, your simple setup and solution, okay, would then be ask yourself, can you take the square root of 9? Yes, you can. Can you take the square root of 6? No, you cannot. Can you do anything else beyond 6? Like, can you simplify it to a 4 or anything like that? Look at your chart. The answer would be what? Be no. So if you know you can't do anything else, square root of 9 is 3. This cannot be solved. There's your answer. Hopefully you guys get that part. Okay, so let's look at this equation over here. Do I know any number that I can multiply by 180? Well, I don't know if I can. I don't know my division properties or multiplication properties of 180 very well, so I'm going to start with, I'll start with the number 9, right? Because I know 9 will go in 18. So let's start with 9, and then it would be, the other number here would be 20. Okay, so I know 20 times 9 is 180, right? And then you can break this down one more time. 2, 5, and 4. All right, so now I'm at a point, ladies and gentlemen, where I have 2 perfect squares here, and then I just have a 5 left over. So remember, this is going to equal square root of 5 times the square root of 4 times the square root of 9. And then you have to ask yourself, can you solve this? Yeah, you can simplify it. Okay, so what is the square root of 9? It is 3. The square root of 4 is 2. And the square root of 5, we don't know, but we know we can't make it any smaller, so we got to stick it out like that. Now, would we leave it written like this? No, you wouldn't. You would want them both 3 times 2. Now, and I put it all, we always put it on the left like this. There's your answer. Okay, hopefully you guys are still following and tracking with me on how we're doing this. Okay, remember, we're always looking for completing the squares. All right, on this one, it's the same philosophy. I want you to actually start, though, by multiplying these together. Because individually, we can't really solve them. But if we multiply it together, okay, we would get the square root of 48. Now, let's look at our numbers. Okay, I'm looking at my board over here. I got 4, I got 9, I got 16. I know I can do 4, so let's start with 4. So if I go 4, then that's going to be 1 and 2, so I know I got 12. And then, can I break 12 down again? I can. I can take 4 into 12. And then lastly, I have 3. So 3 times 4 is 12. 12 times 4 is 48. Now I'm done. Now I have my numbers here, okay? So I have the square root of 3 times the square root of 4 times the square root of 4. Okay, hopefully everybody understands. If I were to multiply all of these together, I would get the square root of 48, right? 12 times 4 is 48. Now you simplify as best you can. Can we simplify this? Yes, we can. This would be 2 times square root of 3. Okay? Now, can you combine anything in there? Yes, you can. 2 times 2 is what? 4. There's that answer. Okay, so what I want you guys to do is follow along with this process. I want you to try these two on your own. So I'll back out. I'll leave this here for a second so you can copy it. Okay, what I want you to do now is please try these two on your own. Okay, try to see if you can multiply them together first, and then look at your table for what are the numbers that will be divisible by, and then fix it from there. Okay, simplify it from there. All right, first and foremost, ladies and gentlemen, 5 times 10 would be the square root of 50. Then if you look at your chart, you should know that 50 is actually can be divisible by 25. So 25 times 2. If I do the square root of these, I can solve this one, and then this one's so small I can't solve it. So you would just drop it down from there, and it would be 5 times the square root of 2. On this one here, ladies and gentlemen, this is the square root of 48. If you remember, we already did this one, but I'll do it again just in case, because I don't really remember what we did. So I know this is 4, and this would be 12, and then this would be 3 and 4. And so I know I have, that's as low as I want to go. So I would have 3 square root of 3 times the square root of 4 times the square root of 4. You can simplify it out, right? 2 times 2, and your answer is, sorry, that square root is bad. Okay, hopefully you guys understand that. Let me rewrite that real quick. Whoops. Okay, square root. All right, so hopefully you guys get the gist of this so far. Now we're going to go down a more complicated road in terms of simplifying these, okay? So we're going to start by making sure, I'm going to show you kind of a long process about this because I want to make sure you guys understand some of the key factors with it. Okay, so what I mean by that is we're going to break this up. So we're going to make this is going to equal the square root of 45 times the square root of a to the 4, okay, times the square root of b to the 5th times the square root of c to the 6th, okay? This and this are the same thing. I'm just blowing it out a little bit because I want to take it piece by piece by piece. All right, so 45. What number would go in? If you guys look at your chart, it would be 9. So 9 times 5, okay? You take a square root of these two. The answer here would be 3 square root of 5, right? Hopefully you guys understand that. Now, the question then becomes, let me give you guys a little demonstration. What is, if I had x squared, 2 squared, and 4. These, ladies and gentlemen, can all be basically representing the same thing. So what I mean by that is that if I take the square root of all three of these, so the square root of 4 is 2. All right? 2 to the power of 2 is 4. So 2 times 2 is 4, right? 2 to the power of 2, meaning there's 2 of them in there, equals, but the square root of that is 2. And so what the square root of this is actually is x, okay? For every 2 variables that you have inside, so if I had the square root of x times x, that equals x, and the square root of 2 times 2 equals 2. What you're doing is you're taking a number and you're cutting it in half, okay? You're taking half of that number. So if I have 2 numbers here, I'm taking half of it, so I'm only left with 1. Okay, so basically if I had 2 pies in my hand and somebody came and took half away from me, I'd only have what? 1 pie left, or 1x. So as you're going through, what I want to make sure you understand, so with the a's, when you guys look at this, we got 1, 2, 3, 4 a's. So as you understand is that if 2 of them equals 1, what you do on this equation then is you realize that for every 2, remember our goal is to get out from underneath this radical. Okay, we want to get everything out. So if 2a's, if I pull these 2 out, 2a's equals 1x, then 2a's equals what? 1a. And if I take 2 more a's out, I get what? Another a. But do we write it like that? No, we don't. Instead, it's a squared. So what you're doing is you're taking this variable and you're dividing it by 2. So in this case here, a to the 4th would be a squared. And then this one here we'll cover in a second. But if you divide this by 2, because remember, that's what we're doing. We have 1, 2, 3, 4, 5, 6 C's under this canopy. Okay? If I take the square root of 2 of them, I'm left with 1. If I take the square root of 2, and if I take the square root of 2, I get 3 C's. Okay, so you're basically dividing it by 2, so I have C to the third. Now the very last piece then is, what about this B to the 5 that's a whole number? Well, I did an illustration in class. If you guys remember your long division, okay? Remember long division. So you have 4 divided by 13. And then, can you answer that? No, but you guys would actually remember, you would say 3. So 4 times 3 is 12. And you're left with something called a remainder. We are leaving stuff behind. That's what we're going to do with this, is the remainder, you put an R1. Okay, you would leave something behind. You left the remainder behind of 1. We're doing the same thing here. Okay, so what I mean by that is, here is the illustration of B to the 5. So I've got 1, 2, 3, 4, 5. Okay, I have 5 of them here. Now, we had talked about, for every 2 that you take out, you can take out 2 of them to equal 1, right? So we'll take out 2 of them here. So we got 1, take out 2 more, we got another 1, but then you have 1 hanging by itself, and that is the remainder that we're leaving behind. So for B, how many B's do we have? It's B squared equals, it would be B squared times the square root of B. Okay, so B to the 5th means you can go 4, like we've been doing here, but you're leaving behind 1 straight one. Every time you have an odd number, you're going to have a remainder. You're going to leave one behind. So this one would be B squared and the square root of B. Okay, so now these are all multiplied together, so we have our equation set up. But we don't leave it like this, because this is weird and it's not fluid, it's not everything together. So what we have to do is we have to write it simply like this, okay? So we rewrite it to put everything together. So hopefully everybody take this, because I'm about to erase this right now. So if you need that, please keep it, or please write it down. Pause the video, back it up. Now we need to put the pieces together. So we're going to put all this together. So what is left over the square root? The 5 and the BR. And remember, these are all multiplying. Okay, so it's multiplying here, multiplying here. So we're just adding everything, multiplying everything back together. So it'll be 5B. Okay? And then, ladies and gentlemen, if you have 5B right here, now what's left? 3A squared, B squared, C to the third, times the square root of 5B. Sorry, my 5s sometimes look like S's. Okay, that is our answer. Simplify this down. You're trying to get as much out of this radical as possible. Okay, and we were able to get quite a bit out. All right, we simplified it down quite a bit. All right, that's a complicated one. Let me walk you through 2 more, ladies and gentlemen, then we'll be done with this lesson. All right, so let's walk through this. We're going to, instead of doing a big giant breakdown, we're going to do it all together in one giant piece. So 32. If you guys look at your initials here, what 2 numbers can go into 32? Student brought it up to me. It would be 2 and 16. 16 times 2 is 32. Okay. Square root, square root. Square root of 16 is 4. That's by itself on the outside. And then over here, I'm going to write the square root of 2. Leave a gap, okay? Because we're going to fill in some blanks here. What would be the square root of r squared? All right, square root of r squared would be r, okay? And then, ladies and gentlemen, what is the square root of k to the 4th? Well, the square root of k to the 4th would be k squared. Remember, you're dividing it by 2. And then what's the square root of t to the 5th? Well, we know that t to the 4th would be t squared, but then we have to unfortunately leave a t behind. So, ladies and gentlemen, there's your equation set up on this one, same as well. 56. I remember we did this in class, but I can't remember if it was 9. Oh, so let me just, I don't remember what it was, so I got to break this one down. So 2, that would be, oh darn it, let me just get a calculator. been a long day. 56 divided by 2 is 28. All right, I can break 28 down into 7 and 4. Okay, and then I can't break. I can't break 7 down any farther because that's a prime number. So, ladies and gentlemen, your setup here is I can do a square root here. So, what would be the square root of 4 times the square root of 7 times the square root of 2? All right, if you set this up, you know your outside number here would be 2. And then you can't simplify these, so you would just multiply them together. 14, okay, just like that. All right, so hopefully you guys understand that. So that's the kind of setup. Now what we're doing is square root of x. Can you do anything with the x? No, you can't, so it has to stay behind. Y to the 10th. What is 10 divided by 2? It would be y to the 5th, and everything gets pulled out. Z to the 5th would be z squared, because you're pulling out 4 of the z's. But remember, unfortunately, because it's an odd number, you have to leave 1 behind. And there's your number there. So, ladies and gentlemen, that is it for this lesson. There are a couple more things on the notes I initially gave you guys, but as we walked through this process and we made the test, we realized that I don't need to teach you some of the other stuff that we had learned. The only other thing I would show you is there is one other aspect I want to show you about, and that is this expression here, okay? I don't think this will be on the quiz, but I want to give you kind of a heads up about if you ever see this in context of where you're at. One thing that I want to make sure with this lesson, and I don't know if I'm going to teach this in class or not, so this will be kind of bonus coverage, is you can never have a radical in the denominator. Okay, so what you have to do is, if I have 3n over the radical of square root of 8, what you have to do is you actually have to use a property of the summative or associate property where you're multiplying everything by 1, okay, to solve the problem. So remember, we can multiply this by 1. Well, I want to get rid of this variable. And how do you get rid of a square root? Is that you would multiply it by another square root. Okay, so what I mean by that is I would multiply this equation like this. Okay, so square root of 8. So I can do this because, ladies and gentlemen, you're basically just multiplying it by, because the square root of 8 over the square root of 8 is what? It's 1. So I'm basically multiplying it by 1, but in a different way. Okay, so now I'll solve this out. So the square root of 8 times the square root of 8 would be 8. And then you multiply this together. So it would be 24, because 8 times 3, square root of 24n. Now you have to ask yourself, can I simplify 24? Well, I'm going to go north with this one. And the answer is, yeah, you can, right? Make a little horns here. What two numbers, so instead of writing it, I'll write it down here on the side. Whoops. What two numbers, ladies and gentlemen, can you actually split? So let's split up 24 real quick. So if I have the square root of 24 and I want to solve it, I can split it up into 4, right? Square root of 4 times the square root of 6. Okay, hopefully you guys are at that point where you understand. Can I go any farther with a 6? I could to 3 and 2, but that doesn't really matter. You got to go back up. But I can perfectly square this, so I would end up with 2 square root of 6, okay, because square root of 4 is 2. So this equation would end up being 2 square root of 6 over 8. Now, are we done? No, you can simplify. 2 divided in 8 is what? 1. So square root of 6 over 4, which is, 6n. Sorry, I forgot the n. Square root of 6n over 4. Here's our answer. Okay. Make sure you guys understand that philosophy and process. Okay. I forgot the n part. Let me make sure I write that a little better as we go forward. Okay. So what I want you guys to do is please try the next one on your own real quick. Okay. See if you guys can solve this one out, and then we'll go from there. Okay. All right, last piece of the puzzle, ladies and gentlemen. Multiply this by square root of 12 times the square root of 12. Okay, so if you do that, you get 12 times 6. So let me put that in a calculator. that would be 72. So I have the square root 72y over 12. Okay. Now for me, as a avid test taker, all right, I'm looking here. My answers. I got a 4 and I got a 2. Okay, so it looks like I'm going to go quite a ways. I'm going to be reducing this down a lot, especially if I have 72y at the top. All right, so what two numbers can multiply into 72? I think, let me see, 8 times 9 is 72. Okay, so square root 72. I do know I got 8 times 9, but, so if I split this, I got 9, which is a perfect, and 8. But 8 can be split down one more time to what? 4 and 2. So if I took the square root of 2, 4, and this. So now I got this. So square root of 2 times square root of 4 times the square root of 9. I can simplify this to 3, 2, and then I can't reduce that. So I end up with 6 square root of 2. So I know that my 72 is that. Okay, so I can rewrite this as 6 square root of 2y all over 12. And if I reduce that, 6 divided by 12 is going to be the square root of 2y over 2. There's my answer. I'll show you guys how to do that one in class as well, but I won't cover too much more than that. We'll have maybe a question, one of those questions on the test. It's very important and imperative that you guys get and understand this concept. Search for the prime numbers. Factor things out. Factor out 4, 9, 16. Reduce it. Some of the other classes, they went really far down a rabbit hole. I don't want you to go that far down. I want you to get to a point like right here where you can stop and say to yourself, can you break this down? You could to threes, but I want you to understand we're looking for simple solutions to stop, okay? You stop here. You don't keep going down. So this would be some other people, when you learn to go down one more time, then you go down one more time to 2, 2, 2, and then 3 and 3. But why? Just understand what you're looking at and look for the prime or the perfect squares. The sooner you get used to the perfect squares, the better it will be for you. Okay, this was a hard lesson. I'm going to have some an exercise in class the day before. I'll try to post that on Canvas so you guys can practice with it. And there's homework as well that I've already uploaded that you guys will be able to practice. If you have any questions, come see me in class. Watch the video again. It should help you. But remember, you're focusing on perfect squares. Okay, you're focusing on finding a 4, a 9, a 16, a 25, a 36 to make your answers smooth and to finish and go as fast as you can. Ladies and gentlemen, good luck. This is just the beginning. We won't really do too much with radicals anymore, but you will cover a lot in Algebra 2. Okay, so good luck for now. All right, we'll go over a bunch of stuff in class, so I hope you make it. In the meantime, have a great night or day, and I will see you soon.